Okay, hi guys. So in this lecture, we'll be starting off with Friedal craft alkylation. So let me write down the heading first. We'll be talking about Friedal craft alkylation. Okay. So let's suppose we have a benzene ring and pass it on in presence of RCl and AlCl3. So we'll get something like this as our product. Okay. And let us discuss the mechanism behind this reaction. We have first step as RCl undergoes reaction with AlCl3. AlCl3 actually uh, or rather Cl minus actually attacks on Al, the empty d orbitals of Al. As a result, R plus is formed and we have AlCl4 minus. Okay. Now in the second step, what actually happens is we have something like this as our benzene structure with these three hydrogen, these two, I'm just showing these two hydrogen, and this benzene ring actually attacks on this positively charged carbocation to form a compound something like HRN, positively charged cation. This is called a rhenium ion or Wieland intermediate, as we discussed in the previous lectures. Okay. Now from this reaction, this is the obviously the intermediate product or intermediate after the transition state. This is the intermediate compound which we get, and after this what happens is this H bond actually, this carbon atom withdraws the bond electrons, and as a result again it becomes negatively charged, or in other words it forms a bond between itself and the positively charged carbon atom. So we get something like, again benzene ring is reformed with H plus is released, and this H plus is again attacked by Cl minus to get HCl plus AlCl3. Okay, so this completes the mechanism of Friedal craft alkylation. Okay, so let us see some examples of the same reaction. Okay, so we'll have something like, if we have a benzene ring and a cyclohexane, what will happen in presence of AlCl3? What will happen is the benzene ring and the cyclohexane ring will form some compound like this. The second example, suppose we have a benzene ring and we have a cyclopentane in presence of AlCl3. What will happen? Again will get something like this as our compound. Okay, or is it okay, let me so I hope you are able to follow the reaction mechanism. This will get a positively charged, and then the benzene ring will actually attack on it. This carbon will get negatively positively charged. Okay, and then H plus would be released from this carbon atom. As a result, double bond would be restored, or the benzene aromatic character would be restored. What happens in this case? We have something like this, presence of AlCl3. So let us see what actually happens in the first step. In the first step, R plus is formed, so plus charge is there on this carbon. So as a result, we can have ring expansion. This bond can actually break up with this carbon atom. As a result, on this carbon atom we'll get a positively charged and 6-member ring is formed. Okay, now this actually benzene ring attacks on this carbocation, and we get the same structure as we saw in the last previous example. Okay, we have something like this. Okay, and we have secondary alcohol attached on cyclohexane in acidic medium and we heat it. What actually happens? This reaction is similar to Friedal-Crafts alkylation except that the reagents are different. Again, alcohols and ethers are stable in in basic medium, not in acidic medium. Hence, this will attack the H plus and get converted into H2O, which will eventually vaporize because of high temperature. And this benzene ring would actually attack on this cyclohexane or positively charged cyclohexane carbocation, and we get something like this. Okay, let's look at another example where we have something like this, and this again in presence of H plus we would be getting it converted into, okay, let's say we have a single bond here. In presence of H plus, first the addition reaction will take place in which this pi bond will break up to form a positive charge and negative charge, and on negative charge this H plus would be attached to, then this benzene ring would actually attack on this carbocation and would form something like this structure. We would have H here, a cyclohexane ring here, and a positive charge here. Again, this H and C bond would be broken up to form a double bond with the neighboring carbon atom, resulting in a benzene and a cyclohexane attached to it, and H plus is also released, which was used up in the previous step. Okay, let us look at sixth example. Herein we have a benzene and something like this compound in presence of AlCl3. What will happen is the Cl will actually attack on Al and form AlCl4 minus, leaving a positive charged cation or carbocation on the compound. This will undergo CS3 minus shift or H minus shift. H minus shift. Why? Migratory aptitude of H minus is more than CS3 minus. Simple reason. So we'll get something like CH3 here and a carbocation here. This carbocation would be attacked by a benzene ring and would get something like this as our product because of electrophilic aromatic substitution reaction. Aromatic substitution reaction. Okay, let us look at the last example for this lecture. We'll have something like this, and this in presence of AlCl3 again. So this bond will be broken up and this Cl minus will actually attack on AlCl3 to form AlCl4 minus, and we'll get something like this as our carbocation. Benzene will react on it and we will get something like this as our final compound. So with this we come to an end of this lecture. In the next lecture also we will be taking on some more examples of Friedal-Crafts alkylation reaction, and till then, good luck and goodbye.